Hello, Space Club sites, and welcome back to another special broadcast of Space Club Career Chats. I hope you guys are having an awesome semester. Keep those submissions coming. Some schools are just getting started with their mission patch and spacesuit. Others are already at that rover challenge, and it's just been really cool seeing all your designs. But today we have another special guest. So today is Dr. Roman Gomez. He's a lead research scientist in the Space Science and Engineering Division at Southwest Research Institute in San Antonio, Texas. He develops, calibrates, and assists with the implementation of and analysis of data from plasma instruments that are currently on spacecraft or shortly due to launch. Well, let's bring him on. Welcome, Dr. Gomez. How are you doing?
Doing well. Thank you for having me on, Natasha.
Yeah, it's great to have you. And we're excited to kind of get your story. I know you do a lot of really cool technical work, but I think you're going to share a little bit about the technical side, but also just like your personal life.
Absolutely. Yeah, just to show you that we don't have to be, how should I say, one-dimensional people.
Right, exactly. All right, well, let me share your screen and I'll be back in a bit.
Okay, so just a quick rundown. So what do I do for a living? And Natasha threw a whole bunch of words out there like calibration and stuff. And basically it boils down to I built stuff that was meant to go in space. And so therefore I have stuff in space. When I'm not looking at that stuff in space, those instruments, I have to think about it. And that's part of my job on a regular basis. And I kind of like that because that means that my job really never stops. And on the plus side, I love my job, so that's great. I also have to go to conferences and talk about stuff in space. And here, this is at the American Geophysical Union meeting in San Francisco, and I conned the security guard into taking a picture of me like that. And then, more importantly, I have to make sure that I talk to people, students like yourselves, about the joys of this profession, so that maybe others of you will want to join in with the fun. And so I end up teaching about stuff in space. I'm teaching a class in astronomy. I also teach a class called the Physics of Superheroes. That's a really, really fun class to teach. I'm trying to work that into so I can teach it to multiple platforms. So my backstory, I got some embarrassing family photos here. So this is my family, my mom and my dad, my brother, the family dog. I am a product of the San Antonio Independent School District. This is a third grade. I completed my high school education in 1988 and then joined the United States Army. Was in the Army for a total of 3 years, then came out, did a few jobs, and then finally started school at UTSA and then went to UT Austin. I ultimately graduated from Southwest Texas State University and have my PhD in astrophysics from Rice. I am also going to be a husband, and I have 2 wonderful daughters. And, things come full circle. You go from being a member of a family to having a family of your own sometimes. Those of you who wanted to know how long I was in school, here's a real quick one. Went to Inez Foster Elementary for 6 years, then Connell Middle School, Highlands High School, and then joined the Army from 1988 to 1991 as an infantryman of all things. Nothing real technical there. When I went to college, I originally was looking at being a medical doctor. And so when I was at UTSA and at UT Austin, I was either a biology or biochemistry major. And then by the time I finished my schooling in biology, I had already caught the physics bug. It's like I tell people that I saw the light, turned to the dark side, and never looked back. And so I ended up with a double major in biology and physics. And then after that, I attended graduate school at Rice University in Houston, Texas. And that took 8 years. I ended up switching my specialties midway through. Originally, I was a astrophysicist looking for dark matter, which is supposedly 23% of the universe, stuff that we haven't been able to see, measure, observe yet. And I finished my master's in that and then switched my field of study to space plasma instrumentation. Again, that's the stuff I build that we put on spacecraft and launch into space. That now I've been doing since I got my PhD in 2011, so 10 years, and honestly, it's just been very, very rewarding. Now, you would think with all this education that, well, does he have time for anything? Well, the answer is absolutely yes, I do. I make time. You have no excuse not to make time. And so I love hiking, love going out to West Texas. It's just beautiful out there. Another thing I've picked up, I've always been trying to be into fitness, and I picked up Olympic weightlifting this year. It's kind of daunting. I'm 51 years old. It's not exactly something you try to get into right off, but I'm enjoying it. And I even go to anime conventions. This is my daughter Rudy. We find I'm actually, so this was at San Japan. This was in September of this year. I've got another one I'm attending in December in Fort Worth, and then one next year that I'm attending in Houston. So I kind of I go and I actually talk about physics and anime and how they kind of represented. And so again, along with that, I get to travel, get to go to Mount Rushmore. Again, this is me acting silly this is at Big Bend National Park. This is called Balanced Rock, and I'm over there trying to pretend like I can lift that. So now to kind of give you an idea, I think I have a little bit of time, hopefully. I'm gonna show you guys a video. See if I can get this back up and running. I just competed in a weightlifting competition this past weekend. And so this is kind of the buildup. So my name is Roman Gomez. I'm 51 years old. I work as an astrophysicist at Southwest Research Institute, and I'm also a part-time college professor at Northwest Vista and St. Mary's, also teaching physics. It's one thing to lift. It satisfies me as a physicist. It's one thing to lift weights moving at a constant speed, and it's another thing entirely to try to accelerate them so you can get underneath them while they're in free fall. So it's very challenging. I think what got me trying this is I actually was at Gold's Gym and I tried to do snatch one time, and just with an empty bar, and fell flat on my butt. And I said, if I'm going to try this, I'm going to need to get a trainer. And so I reached out, and a personal friend recommended me to Rogelio. I feel pretty strong. All the technique that is required, we've been working it, and Rogelio's just been very, dogged on the technique, making sure that I, do things correctly, and one of the things I really enjoy about working with him is that, you've got repetition. That repetition makes things work, makes things second nature. And so, going into my first meet, which is really exciting and kind of intimidating, I feel really good. I feel really good.
Well, are you just trying to make scientists look cool?
Hopefully, I'd like to think we are.
No, I love that you shared that video because a lot of the students have this stereotype of when we hear scientists, they think like Big Bang Theory, right? Like super nerd, which we have to admit that scientists are nerds
Oh yeah.
sometimes. But you have like so many different layers, just like any other person. So I love that you shared all those sides. And if you have a couple more minutes, I'd love to ask you some more questions from the
By all
kids.
means.
So you alluded to this question. How long did you go to college for and just school in general? And have you done the math on how many years total?
Well, so yeah, it was so 12 years. Well, actually, like 13 if you include kindergarten, right? So
Yep.
13 years, from kindergarten to high school. Then college, I bounced around, so that was 7 years. So then
Yeah,
at that
it's a lot.
point, we're at like 19 years, right? Is that what it is? Yes. And then grad school was 8. So yeah, God, almost a little bit over 2 decades that I was in
Yeah,
college.
36 years is what I added.
Yeah, it is. And again, there was some time. I took a year off in college, and I didn't go to college right after high school because I joined the military. There were some
Right.
things in there, and they were learning experiences as well. There were certain things that I needed to develop, certain disciplinary attitudes, and the military was really good for that.
I think one of the concerns that students have, they're like, oh my gosh, that's so much school. How do you approach school and learning in general? Because I think kids are afraid of it and see it as just a burden.
It's funny. My father always told me that education was a reward in and of itself, and that nothing worth having was ever going to be an easy thing to attain. I think maybe, and I don't know if my statistics may be biased, but I think it's like 16% of the American population has a bachelor's degree. 1% has a PhD in physics, and probably about 1% of that has a PhD in astrophysics. It's the most rewarding, one of the most rewarding things I've ever done, but it was not easy to get here. And it's kind of like with lifting the weights. I want to compete, but if I'm just walking into the gym like once a month and like, okay, I'm going to get stronger, that's can be then diluting myself. So if it's something you want, if it's something you desire, and if it's something you love, and never be afraid to fall in love with something like that, then go after it with gusto. Throw your passion into it, throw everything you are at it, and you will give back. And all that time that you invested will seem like nothing. It's like, what, this was time well spent. That's how I feel.
I like the weightlifting analogy because it's, different type of muscle. You're trying to grow that brain, that thinking power. And one of the questions I had, I want to see how you answer this. Do you really learn from your mistakes? How? This is a group of girls in Illinois.
Yes, absolutely. I mean, I tell my students this all the time, that you're looking at a creature that has been born and forged more from his mistakes than from his successes. And each of those mistakes, those, problems with a calculation, or maybe I didn't measure something correctly on my apparatus, or when I constructed it, there was something missing, and I learned from that. I didn't do that again. And that led to ultimately, all successes are piled on a whole heap of misdirection and mistakes. And it's okay. And as a matter of fact, when you're studying, that's the time to make a mistake, right? When you're in your class and you make that math mistake or something like that, don't feel bad about it, incalculate it, and make it a part of you. And then say, okay, I'm not going to do that again. Because I think I was telling some students I was teaching engineering physics to, I said, look, wouldn't you rather make the mistake in this class and have me correct you, and then you learn from it, than you be working on that multi-million-dollar bridge and have a problem with your design, or you be working on that multi-billion-dollar spacecraft and have a problem in your design, and all of a sudden everything's broken. So yes, mistakes are important and you should learn from them.
Yeah, that's great. Okay, so let's talk a little bit about your job. What is your least and most favorite part of your job?
Let's see. The least favorite part of my job is paperwork
Did you
and
say people?
paperwork.
Oh,
No, no, no. I like
paperwork.
people. It's it. I like I like doing the experiments. Sometimes writing about them is always tough. And then in my field, you have to write proposals. And I'm not a bad writer. It's just that I'd much rather be in the lab doing things. And that's why I'm an experimentalist. But that being said, once you get into the rhythm of it, it's not so bad. My favorite part, I just mentioned it. I love being in the lab. I love tweaking things. I love putting things together. Again, that's why I chose to be an experimentalist and not just a theorist. I think if you're going to be an experimental physicist, you have to have a strong grasp of the theory, but you have to be able to work with your hands. You've got to be able to use screwdrivers and learn how to build circuits and learn how to work with vacuum systems. And that's something I've always liked, just a visceral sense of the physicality of it. And that's not for everyone. There are some people who like being modelers and theorists, people who are extraordinarily strong at mathematics, and they end up going that route. So, but I like hands-on stuff.
What are other types of people that you work with? So we've had some other scientists, we've talked to a couple engineers. Do you work with other disciplines?
Oh yeah, I work with chemists. I work with geologists. I work with people who are particle physicists. I work very heavily with engineers because when I design an instrument, for ion optics or something like that, then I have to go and talk to the engineer to put it to construct it for me. It's a division of labor thing. And could I build the instrument? Could I design it? Yes, but the engineer is much faster. I work with computer programmers. Can I write code? Yes, but can I write it as efficiently as a computer programmer? No. That said, I do write code that is specific to my tasks. But when I need a more generalized code, I just call in a computer programmer, and we work very well together. And it's really funny. Again, scientists are always kind of put forward in this like antisocial. I got to be social. I really do. I have to learn how to get along with people. And that being said, I've made some really great friendships with the people who I work with. It's just long time, and I can always depend on them.
Switching to more of your backstory, who was your greatest inspiration growing up?
God. So a lot of people would expect it to be Einstein, but no. Enrico Fermi is my favorite physicist because he embodied this kind of equal and amazing potential in both experimental and theoretical physics. That was who I would aspire to be. He was just a neat guy. And at one time he had under his employ one of the greatest collections of minds. This was in Italy. And just really, really sharp guy. He worked on the Manhattan Project. I mean, I think that would be that would be the greatest inspiration.
So as a kid, how did you come across him? Was it in a class? You found a book?
I found a book.
Okay.
I was kind of a World War II buff when I was a kid. And you read about these physicists who participated in the Manhattan Project. And the one again who really kind of struck me was Enrico Fermi. That project basically hinged on his know-how. If he was not there, they would not have been able to perform the reactions required in order to get the products they needed. And I always thought that was cool to be like that one guy that you have to depend on, that one person that is the crux. It always fascinates me how, even though we have all these great collective efforts, all of the advances are generally made at the individual level. One scientist or one engineer. And that means that everybody has a part to play, and that one piece fits into this giant lattice that is, either a success or failure.
Yeah, that's great. All right, one more question for you. This kind of feels like an interview question, but I think it's good. So Team Apollo wants to know, where do you see yourself in 5 years?
Hopefully still lifting weights.
Yeah.
No, in addition to that, God, I mean, it's kind of funny. I mean, I could see myself possibly as in a higher leadership role than I already am on the current projects that I'm in. But otherwise, that I'm happy where I am. This again, that whole thing. My father told me, find something you love to do, get paid to do it, and you'll never work a day in your life. And I honestly have not worked for the past 14 years, and I don't intend to start anytime soon. Will I have opportunities to field more instruments? Yes. As a matter of fact, I have 2 upcoming missions. One is going to be making a measurement of the solar wind. I am designing the solar wind instrument for the next almost decade. Wow. That's kind of an honor. I've got another instrument that's going to be in near Earth orbit. We just finished the review of another instrument. I'm providing a similar instrument to that mission, and that one would launch, because we have 2 launching in 2024, and that one would launch in 2026. So, I mean, I'm spoken for, and that's kind of a good feeling.
Yeah. Well, that's awesome. And we will bring you back, I think, for more Space Club career chats to kind of see your progress.
Sure.
And also in weightlifting, good luck with that
thank you.
tournament. But before we end, I would love to share with you some of the highlights of this week of the Space Club students. Okay. So let me pull those up. I have your screen. Let me change
it. My screen.
I got it. Okay. So these are some of the projects from this week. This is a school, Calvary Christian School in Illinois. I see some robot hands down here at the bottom. This is hard to tell, but they're actually learning about hydroponics up here, which is actually a pretty critical technology that NASA's developing.
Yeah, when I was in high school, I actually worked on hydroponics, and so the we were already talking about it back there, in those ancient days when dinosaurs roamed the earth. But I think it's amazing that has moved forward in the way that it does, because that's for colonization purposes, hydroponics is absolutely vital.
And good tip, because the final project is to design a base on the moon. And so the kids need to keep in mind hydroponics as a potential solution. So Anthony Akers in Wisconsin. So what they do, and I'm glad you shared your weightlifting. So the kids all tell us what their spark is, what they're passionate about. Mm-hmm. And so they create a mission patch that represents that. And then here at the end, can you tell what this is?
That looks like an inclined plane, but
yeah, they're trying to build a roller coaster.
Okay, cool. I love roller coasters so much.
Classic physics.
It's the best use of kinetic energy I know of.
Yep. All right, Cedar Drive Middle School in New Jersey. They have their spacesuit, which I just noticed there's like a cup coming out of the middle. I'm thinking is oxygen. I'm not sure what that represents. Any ideas?
Or it could be a way to get nutrients into it. I mean, that's.
Yeah. And then another hydroponics device. We have an international school in Kuwait, Indian Central School, that's participating. They're on their rover challenge. And so here they're transporting this rock sample they collected on the moon. And you can see some pretty creative designs.
I think that's really important. That type of technology, if you're ever going to go and visit a planet, the first thing you're going to do is send unmanned vehicles there. So, and making them as intricate and as not complicated, but as capable as possible is really, really important.
Another good tip for our base coming up. Some more projects from Kuwait. This is the robot hand. And so the idea with these robotic arms is this kind of extension to pick up samples, and then the rover transports it.
And protecting a manned mission is, of utmost importance. So yeah, any way you can do it.
A few roller coaster designs here from Magazine School in Arkansas. And we connected this to the Vomit Comet in astronaut training and experiencing changes in acceleration. hopefully their roller coaster does not cause people to vomit, but
But those are the only good ones, though.
I guess if that's your goal. And then I think this is our last one, Wilkins Junior High in Illinois, also doing their robotic arm. And I will say, guys, this is one of the hardest challenges because it seems simple, but it's really intricate to create all the fingers and to make all these movable parts. So I just want to say good job to all the teams.
Absolutely.
All right. So the final part the kids are all excited for is the raffle. And we've given away NASA swag and microscopes. And this week, our team is going to get a headset for augmented reality or virtual reality. And so you could actually do a roller coaster. There's a really cool VR game, and there's like an underwater adventure. There is space, so you could be like an astronaut on the moon, exploring the moon. So
I
really
am
cool
jealous.
stuff.
I am jealous.
You're jealous. All right. Well, let's see who wins this. Let me pull up our picker wheel. Last time I did this, it played an advertisement. So I hope, okay, good. It's always brought to you by somebody. So I think it was over 50 teams submitted this week. So let's see who our winner is. Congratulations, my Lester Stevens Junior High, the Turtle Knees Shuttle. What a unique name. All right, I am going to be contacting your teacher. But as we wrap up this Space Club career chat, Dr. Gomez, do you have any final words of advice or thoughts for our students?
I mean, I think I can't focus enough on passion and having grit, because, you know, it sounds funny. The only person who can motivate you is you. Ultimately, teachers can try to push you forward, but you're going to have to pick yourself up by your bootstraps. Now, that being said, you know, you will find people who will be willing to mentor you, and you know, just never give up. You know, always eyes on the prize, push forward, look for people like me who are more than happy to mentor, and you'll get to where you want to go. You'll get to where you want to be.
Even if it takes you 36 years.
And if it takes you 30 or 40 years, absolutely.
It's worth it in the end.
Absolutely.
All right. Well, thank you again for joining us.
Thank you for having me.
Great job to all the students. You guys have a great rest of your week, and I will see you next time.
Okay.
Bye.